Good morning, dear students. I welcome you all to this video lecture. So in this video lecture, we will be going through this new chapter on triangles, which is part of your geometry section. So as you know, triangle is nothing but a three-sided closed figure. So this three-sided closed figure will have 6 components. Those 6 components are 3 sides, that is sides AB, AC, BC, and also angles, angle A, angle B, and angle C. At times, at angle A we can write it as angle BAC in a proper way, and angle B I can write it as angle CBA or ABC. So this is the proper way to write angles. So before we move ahead, all of you should know what do you mean by angle sum property. So angle sum property tells us that in a triangle the sum of all the 3 angles, that is angle A, angle B, and angle C, will become 180 degree. So please keep in mind that the total sum of all the angles in a triangle will be 180 degree. So let us move ahead with the other slide. Now in this chapter we are going to discuss about congruence. So congruence, the spelling is slightly incorrect. Congruence, there should be only one U. So let me just correct it. It will be congruence. Okay, so we are going to discuss about congruence of a triangle. So 2 triangles are said to be congruent to each other if they have, let me just use a different color, if they have the same shape and the same size. So if you see in the first diagram, they might be having the same shape. If you see properly, if they might be having the same shape but they are not having the same size, so we can say that. In the second case also, they might be having the same size but they are not having the same shape. So these 2 triangles, we cannot say that they are congruent to each other. So for any 2 triangles to be congruent, they have to be of the same shape and the same size. Something like, we can say that if a book is in a form of a triangles and we are publishing the same book, so we can say that those 2 books will be congruent to each other, because if I keep one book over the other book, it will completely hide the book that is below it. Okay, so we can say that those 2 books which are in a triangular form, we can say that those 2 books are congruent because they are having the same shape and same size. So let us move ahead, and if we get that triangle ABC and triangle PQ are congruent, so we use this notation. It's written something like this. On top of equals to, there will be some kind of wave sign. So we can say that triangle ABC is congruent to triangle PQR. It is read like that. Before we move ahead, you need to understand the concept of corresponding. Corresponding meant related to each other. Please be clear about the concept on corresponding. So if you see over here, I have drawn 2 triangles, that is triangle ABC and triangle PQR. What do you mean by corresponding is, A is corresponding to P, B is corresponding to Q, C is corresponding to R. So why this correspondence is very much necessary in this section is because I can say triangle ABC is congruent to triangle PQR only based on if A is corresponding to B and B is corresponding to Q and C is corresponding to R. Suppose if something like A was corresponding to something like Q, what I want to say is that if I keep 2 triangles on top of each other, something like A, B and C, and one more triangle if I have over here, which is PQR, then they will be congruent if and only if A is being corresponding to P and B is corresponding to Q and C is corresponding to R. But same way, if I keep this triangle something like this, A, B and C, and I can even keep the other triangle something like this, right? I can even keep it as I think that's not the way. This is PQR also I can keep it. But in this way, we cannot say that those 2 are congruent triangles. So corresponding is very much essential whenever we go through congruence of 2 triangles. So I hope everyone is clear with the concept of corresponding. So A has to be corresponding to P, then and only then, in that way only we can say that those 2 triangles are congruent to each other. So let us move ahead and discuss. Okay, so this, if you see the triangle in the previous slide, if they are congruent, then angle A should be equal to angle P, will be equal to angle P, angle B will be equal to angle Q, angle C will be equal to angle R, AB will be equal to PQ, BC will be equal to QR, and AC will be equal to PR. So if you can see that diagram properly, all these things will be there. Then and only then we will be able to say that those two triangles are congruent. Now we are going to discuss about the criterion or the criteria based on which we can say that those two triangles will be congruent. Although here it looks like we have to show 6 different properties to be equal, but as we go through you will come to know that all the 6 properties are not necessary to show that something is congruent. So let us discuss about some of the criterions or criteria based on which we can say that two triangles are congruent to each other. So let's start with this statement, which reads something like this. Two triangles are congruent if the 3 sides of one triangle are equal to the 3 sides of another triangle. So what we can infer from this statement is these two triangles ABC and PQR will be congruent if and only if AB equals to PQ, BC equals to QR, AC equals to PR. Again, please remember the word corresponding. Here I could not have said the same about congruency if AB was equal to something like some other side. Let's take it QR. Okay, so the corresponding sides only has to be equal. Other sides we are not bothered about it. Please keep that in mind. So this condition is also known as SSS. That means side, side, side. If we can show that 3 sides are congruent, 3 sides are equal to each other, we can infer that those two triangles will be equal. Not equal, it will be congruent. So let us move ahead and discuss some more criterions. Second criterion is also known as SAS, which reads something like this. Two triangles are congruent if 2 sides and the included angle of one triangle are equal to 2 sides and the included angle of another triangle. So what this theorem tells us is that if I have, let me just use some other color. If I have 2 sides to be equal, say PQ equals to AB and QR equals to BC, and also the included angle. Remember, the word included is very much essential here. We are not discussing about any other angles but the included angle. So if you see which is the angle that is included by the 2 sides is this one, right? Here Q and here B. So if all these 3 conditions are satisfied, that is PQ equals to AB, QR equals to BC, and the included angle, that is angle Q equals to angle B, we can say that those two triangles are congruent to each other. Please remember the word included. Here, if I would have had PQ equals to AB, QR equals to BC, and instead of having angle Q equals to angle B, if I had something like other angle, say angle R equals to angle C, this would not have satisfied the conditions of our theorem. So we could not have told that those two triangles will be congruent to each other. So let us move ahead with some more conditions. This is known as ASA, that is angle side angle. Two triangles are congruent if 2 angles and the included side of one triangle are equal to 2 angles and the included side of other triangle. So if you see over here, if I have angle A equals to angle P and angle B equals to angle Q, so that means these two are equal, and also the included side, so which is the common side to both the angle, that is AB over here, and over here it is PQ. So if I have these 3 conditions to be satisfied, then I can say that those two triangles are congruent to each other. I hope that clarifies things. So please remember again, the word included is very much essential. That side has to be included in both of the angles, then and only then I can use this condition. So let us move ahead. So I have one more conditions. Two triangles are congruent if any 2 pairs of angles and a pair of corresponding sides are equal. So I can have these 2 angles to be equal, say angle A equals to angle P, angle B equals to angle Q, so that means these 2 angles are equal, and any of the corresponding sides, that is AC equals to BR, any of the corresponding sides, but it has to be corresponding. I can't write it AC equals to some PQ. AC has to be equal to BR. Yes. So in that situation, under these 3 conditions, I can again say that those two triangles will be congruent to each other. So we have come across different conditions based on which I can say that two triangles will be congruent to each other. Now let us discuss the last condition. It is about right angle triangles. So that is right angle triangle. I think I have missed over here, or excuse me. So I have missed over here one word. So that has to be angled. So it will be two right angled triangles are congruent if the hypotenuse and one side of one triangle are equal to the hypotenuse and one side of the other triangle. So hypotenuse, if you see here, you are very much familiar with the concept of hypotenuse since we have already finished the chapter on trigonometry. This AC should be equal to PQ and any of the two corresponding sides, right? So either AB equals to BC, AB equals to PQ, or BC equals to, I think this should be PE. So let me just name it properly. I think I need to keep this as R. So let me just keep it PR. Yes, AC equals to PR. So BC should be equal to QR. AB equals to PQ and BC equals to QR. If this is satisfied and any one of this condition is satisfied, then using these two conditions I can say that two triangles will be congruent to each other. So this was all things that is required for us to start solving the exercise problems. So based on this, in the upcoming classes we are going to solve some problems and look after its applications, how we can use it, all these theorems. So with this I finish this video lecture. Thank you all of you for your patient listening. Thank you.